A particle projected from the origin, O, passed horizontally through a point with a position vector of 10I plus 10j meters, where I and j are horizontal and vertical unit vectors respectively. Determine the velocity with which the particle left O, considering the acceleration due to gravity to be 9.8 meters per square second. It can be really useful to simply begin by sketching a diagram of the motion of the particle. We know that the particle is projected from the origin O. We don't know its initial velocity, so let's call that u. We can split that initial velocity into its horizontal and vertical components. Let's call the horizontal component for the initial velocity u sub x, and the vertical component u sub y. There is a moment when the particle is passing horizontally through a point. This must be at the highest point the particle reaches. We know this occurs when the vertical velocity is equal to 0. And we know at this point the position vector is 10I plus 10j meters. And then we can see that acceleration due to gravity is 9.8 meters per second in the downward direction. What we're going to do is split the motion up into its horizontal components and its vertical components. Horizontally, we defined the initial velocity to be equal to u sub x. This is essentially what we're going to be finding. There is no acceleration that acts on this particle in the horizontal direction. And this means that its horizontal velocity never changes, so its horizontal velocity at any point will also be u sub x. We're interested in a horizontal displacement of 10 meters, and we don't know the time at which this occurs. We defined the initial vertical velocity to be uy, and then the vertical component for acceleration acts in the opposite direction. It's acceleration due to gravity, and we define that to be negative 9.8. We're interested in the highest point of our arc, and we said this occurs when the vertical velocity is equal to 0. And that's because at this point the particle changes direction, so there is an instantaneous moment that its velocity is equal to 0. The vertical component for the displacement at this point is 10, and yet again we don't know the time at which this occurs. We have actually got enough information to work out the vertical component for the initial velocity. We're looking to find u, we know a, v and s, and so we use one of our equations of constant acceleration. These are sometimes called SUVAT equations because of the acronym the letters make. We're not really interested in the time at this point, so we're going to use the equation v squared equals u squared plus 2as. V is equal to 0. U is equal to uy, remember that's what we're trying to find, so we write uy squared. And then we want 2 times a times s, that's 2 times negative 9.8 times 10. This simplifies to 0 equals uy squared minus 196. We add 196 to both sides, and then we're going to square root both sides of the equation. The square root of 196 is 14, and we're not interested in the negative square root because we define the initial velocity to be in the positive direction. So we found the value of uy, but how do we find ux? Well, we are able now to calculate the time at which the particle reaches this position. We're going to continue looking at the vertical motion, this time using the formula v equals u plus at. Substituting what we know about our vertical motion, and we get 0 equals 14 minus 9.8t. We add 9.8t to both sides, and then divide through by 9.8. And that gives us 10/7. So we now have enough information to work out ux in the horizontal direction. This time we're going to use this equation, s equals a half u plus vt. We substitute what we know about the horizontal motion, and we get 10 equals a half times u sub x plus u sub x times 10/7. This simplifies on the right hand side to u sub x times 10/7, and we divide through by 10/7. And we find u sub x to be equal to 7. We now know the horizontal and vertical components for the initial velocity, and so we can say that the initial velocity with which the particle left O is 7I plus 14j meters per second.